Alright, howdy. My voice is gone, so this is going to be interesting. We have another problem to look at. Exchange seats on LeetCode. Let's give it a shot. Oh, actually, let me go back. I want to open this up in another window. So exchange seats on LeetCode. Let's give it a shot. I've not seen this problem yet, so this is going to be new to me. Oh no, it's SQL. Hold on a second. I guess we'll do some SQL here. We will do some SQL. Let me change from C++ to SQL. And I guess we're going to do MySQL. Only have a few options here, MySQL and Oracle. So I guess MySQL. Syntax, sure. Sure, there are other databases out there other than Microsoft's database, but okay. Okay. Alrighty, so that is not a C++ program. That's not a C++ program. Mary is a teacher in middle school. She has the table seat storing students' names with their corresponding seat IDs. The column ID is continuous increment. Okay. Mary wants to change seats for the adjacent students. Can you write a SQL query to output the result from Mary? For the sample input, the output is Abbott, Doris, Emerson. Doris and Abbott. Oh, excuse me. Doris goes up to the top. Abbott, Green, Emerson. Oh, looks like everybody's moved. The number of students is odd. There is no need to change the last one's seat. Whoa, okay. What? So, James, I'm so confused. James stays, Emerson goes down, Green, what is going on? Oh, and Jason, oh, I see. I understand. Okay. And you don't change the ID though, you just change the student. Alright, fair enough. Sure. How can we do that? Alright, let's just start with some basic SQL, right? Select from seat, and let's just print that. Excuse me. Now, one thing I've been thinking about. Okay. ID, student values. Alright, so I want to swap every other pair. How can we do that? So, well, I don't know. I don't know. How might we achieve that? Well, you could create a join and then a joined table and then swap and then select from the joined table the records that we want, right? The ID and the student. So I guess the IDs basically don't change. That's pretty much. We're just going to try to select the student, modify the student. Now the tricky thing though is you can do what's like a this is a tricky thing. I want to do a join where the ID is offset by 1. I guess we could do 2 joins. We could do a join where the ID is incremented by 1 and a join where the ID is decremented by 1. And there's a like a right-hand join, a left-hand join. I guess we don't want to do a natural join. We actually want to join where there could be null elements. And so what can happen is, so we do a right-hand join and a left-hand join. Let's say we do a right-hand join with all of the students that have an ID incremented by 1, right? So next to Abbott, you would end up with Doris. Next to Doris, you'd end up with Emerson. Next to Emerson, you'd end up with Green. And then the other join, where we decrement by 1, we would say, so Abbott would get nothing. Doris would get Abbott. Emerson would get Doris. Green would get Emerson, and James would get Green, right? And obviously James wouldn't get anything for the other side, for the ones, the +1, right? James would get null. So we have a shifted down and shifted up. These two tables would be joined. And then what you can do is on the first ID, if it's even, if the ID is even, then you can take the student to be, so we would know there's the shift down and shift up tables, right, that have been joined. You can take for the odd IDs, you actually want the shift up. So you take the shift up student values from the odd for each odd ID, and if the ID is even, you would actually only take from the shift down, right? So when you're looking at Doris, you'd end up with Abbott. So Abbott, you would get Doris. Doris, you get Abbott. You can do it in this way. Somewhat wasteful, but yeah. So you have these two subqueries, these joins, which could be empty. But you join for the student ID, students, and you can take the IDs on the students. Doesn't really matter. You just rename them as, sort of up and down, up.id and down up.student and down.id down.student kind of thing. And then you would get the swap that you're looking for. So I think that works. We can give that a shot. How are we doing? 7 minutes in? Now the question is, how do we do those things? We have to double check SQL join. I don't remember how to do that at all. Also, I guess MySQL, I think you might have variables in MySQL. I don't know. So let's try to join some examples. Left join. Yeah, so let's do a right join. Left join does what? They say left join. Inner join, we don't want to inner join. There's left join, right join, inner join. We actually want, I think, a right join. Not a natural left join. Is defined to be semantically equivalent to an inner join or left join with a using clause that names all columns that exist in both tables. Okay, but we don't want a left join. Right join works analogously to left join to keep code protocol across databases. It's recommended to use left join instead of right join. Oh, okay, they do the same thing. Alright. So it's an outer join we're looking for. The outer join shown in the join syntax description exists for compatibility with ODBC. The curly braces in the syntax should be written literally. They are not meta syntax used elsewhere in syntax descriptions. Oh, I see. Outer join. Basically, we're going to perform outer joins. An inner join is sort of like a natural join. Straight join is similar to join, except the left table is always read before the right table. This can be used for those few cases for which the join optimizer processes the tables in a suboptimal order. Interesting. Where do we explain a left join? Join expression refers to a partition table, may contain a partition clause, including a list of common separated partitions, subpartitions, or both. Follows the name of the table and precedes any alias declaration. I guess you could technically partition the table. I don't really know much about partitioning the table. The fact that this option is that rows are selected only from the listed partitions or subpartitions. Any partitions or subpartitions not named in the list are ignored. For information example, see section 22.5. Partition selection. The syntax of table factor is extended in MySQL, and in comparison with standard SQL, the standard accepts only table reference, not a list of them inside a pair of parentheses. Interesting. There is a conservative extension if each comma in a list of table reference items is considered as equivalent to an inner join. For example, on and is equivalent to cross join on. Okay, interesting. You can use commas. I get it. I think I get it. Left join, cross join, join, cross join, inner join are syntactical equivalents. They can replace each other. Standard SQL, they are not equivalent. Inner join is used with an on clause. Cross join is used otherwise. Okay. So inner join has an on, and cross join is. Alright, but all this cross join, inner join, and join are all the same. Okay. Parentheses can be ignored. Nested join optimization. Index hints can be specified to affect how MySQL optimizer makes use of indices. Index hints, optimizer hint switchable optimizations. Okay. Table subquery. Maximum number of tables that can be referenced. Single join is 61. That's fine. Semantic equivalent in the absence of a join condition. Both produce a Cartesian product between the specified tables. That is, each and every row in the first table is joined each and every row in the second table. Excuse me. Inner join and comma are semantically equivalent in the absence of a join condition. Fair enough. Precedence of the comma operator is less than inner join, cross join, left join, and so on. Mix comma joins with the other join. Join. Suddenly thought about groin. If you just said the word groin 100 times in 5 minutes, the meaning would start to get pretty distorted in your mind. Join. Join types when there is a join condition, an error of the form unknown column name in on clause maker. Information about dealing with this problem is given later in the section. Okay, so you can don't mix commas with joins, I guess. I don't think it's a good idea to really use that ever, quite frankly. If you could avoid it, unless it's like really makes things a lot simpler. Search condition used, I think it just obfuscates the meaning too much semantically. Probably not a good idea to use it. Search condition used with on is any conditional expression of the form that can be used in a where clause. Generally, the on clause serves for conditions that specify how to join the tables, and the where clause restricts which rows to include in the result set. Oh, that's interesting. Yeah. A little confusing. There's an on and a where. An on specifies how to join the tables. The where specifies what will end up in the result set. There's no matching row for the right table in the on using part in a left join. A row with all columns set to null is used for the right table. Right, there you go. You can use this fact to find rows in a table of no counterpart in another table. Yeah. So that's what we want for the left join. Left join and right join are analogous, but left basically means the right table will just get a null row. That's what I was looking for to verify that. Excuse me. So here you can do, yeah, all right, so we want left joins. So we want select from seat, and we're going to say left join. Left join with seat. where, or we'll say on left table ID equals on left join right table. Do seat as X, left join seat as Y, on Y, on, we're going to say x.id, so this we're going to call this, we'll call it up as up, and we're going to say x.id equals up.id plus 1, and then we're going to say left join seat as down, x.id equals down.id plus 1. On, and it's going to be the other way around. Something like this. So we want the to be up, we want the right side to be values where the ID actually shifted up means that the IDs that are included, it's actually the rows that are included, the ID is decremented, right? So Doris will be up. So it's actually the other way around. It's -1, +1. But I think and actually these are, it's interesting in C++ you have a double equals for equality. In SQL, MySQL, you have a single equals for equality. And I should whisper because my voice is killing me here. Now we're gonna make this a subquery that we select from. But yeah, I should whisper because my voice is disappearing, right? So it's null, so 1 habit, 2 doors, null, 2 doors, 3 Emerson, 1 habit, right? So now we have access to, each row has access to the below and the above. And now we would say, now we can get the subquery. So this is going to be itself a subquery, so we're going to run that subquery as it is. Select ID, where it's going to be ID and student from the subquery, where, and then we want to say conditionally, right? It's going to be something like this. ID is going to be equal to, so really it's going to be something like if statements. Can I do this actually? I don't know. If the if statement, okay. If search condition, then else. That's what we want. All right. If function differs from the if statement. Okay. If statement can have with end if. Okay. Might want to use the if function. Create function, begin, return, end. We might want the if function, not the if statement. So can we use an if? Maybe the if function is what we want. I think it's the if function, probably not the if statement. So we have expression 1 and 2 other expressions, right? First expression is divisible by 2. say something like, I actually don't know. We say, let's say as sub, right? And we say if sub.id modulo 2 equals 0. Have these two other expressions, right? So if sub ID is and we would say something like where ID equals sub.id and not ID but student is equal to if sub.id modulo 2 equals 0, then we have two expressions, two possibilities. We'll say return it would be sub, well, I guess you'd want, like, I don't know, I'm confused with this subquery exactly how to name things. You probably want, I don't know, ID1 or ID student, and then it's going to be like up ID, up student, down ID, down student, something like this. How about that? Can we do this? Let's see what happens if we do this. Child column ID and field list is ambiguous. Okay. So these are just, how do I refer back to this subquery? ID is ambiguous. Okay, can we do over this x.id, x.student, and then, or we could say as ID. I think you can do something like this: as student, up ID, and say up.id as up ID. Let's try that. Let's try each of these as their own field names. Up.student as up student. Down.id as down ID. Down.student as down student. Something like this. How about this? What happens when we do this? I want to modify the head of our return statement. Oh, there we go. It works. Okay, perfect. That's what we want. Okay. I want to name each of these things. Now, I guess my question is, if we select, ID student from the subquery, right? What does this look like now? Oops, I didn't mean to do that. What does this look like now? Alright, interesting. So we get ID student. How about up ID and student and up student? What does that give us? And let's also try sub as well, the syntax. So that gives us what we want, but how about sub? Does that work too? That would be interesting. It does work. That's really interesting. Now finally, let's do let's do x.id and sub.x.student, or rather let's do Let's do up ID and up ID. I'm sorry, up ID and up student. Let's have sub.up. How about this? Would this give us these as well? Just a curious thing. Runtime error, duplicate column name ID. Okay. Fair enough. Fair enough. So it doesn't quite work. Alright. It looks like we need to give each of these aliases, which is not really ideal. It works out okay in this case, but not exactly how I would like to do things. Though we can do this, I guess. Alright, so we can go back to what we had here. So take ID student, and I want to say where ID equals sub ID, and so now actually what we want is, this is kind of confusing. I don't know if this actually works, but what we want is it's going to be, oh, I see. Oh, that's interesting. So I don't know if we can do it this way, but all we want to do is we're going to select as ID and as student, but we want to set. So that's really interesting. So that's super interesting. So we would, oh, I gotta sit down for a minute now thinking about this. I don't know if this works. Because if you want to return, like we have all the data that we need from each row, but the issue is we want to create a new subquery that in the even cases, so yeah, in the odd cases, we take the up student, and in the even cases we take the down student. That's the idea, if it exists. Otherwise, we don't change it at all. Interesting. But the problem is that the where clause is conditional. It's not actually specifying which student that we take as our variable. Well, that's very awkward, huh? Excuse me. Interesting. Maybe we need to write a couple subqueries then, so we can say maybe we can join again, I guess, I don't know. I don't know, I'm struggling now. I actually don't know. I don't know the answer. Because we can rename things. We can rename columns. But we cannot rewrite only certain rows of the columns. I don't think it exactly works like that. Yeah, I don't know. Like what we can do is we can if we can generate the row that we're looking for, we can rename it to student. Or the column that we're looking for with all the rows set in the right spots. That definitely we can do. But how do we interleave? I guess we kind of want to run like an update command. It's like an update subquery or something. That's really what we're looking for. Can we do that in MySQL? Maybe we can. Let's see. Let's see if we can do that. Let's also see how we're doing on time. 30 minutes, okay. I don't do a heck of a lot of SQL, so I tend to struggle quite a bit. It tends to take me a lot of time. Um, I don't think you can. I mean, you could do an update. Can you update a subquery? I don't think so. I don't know, man. So I guess you can update as a subquery. We could try it, see what happens. Yeah. And we say set where update. is looking for a select statement, not an update statement. Okay. Let's just try to update here, see what happens. How about this? Select after the update as a subquery. Yeah, okay. Yeah, we can't run an update subroutine, I think, or a subquery. I don't think so. Cool. Let's try just update set ID equals ID plus 1. Let's try that. Just verify that these comments are working as expected. Oh no. We're not. Okay. What happened to my multi-line comments? Oh, I see. But I can't do that because I can only run one line at a time in my SQL here. Alright, anyway. Annoying, but that's okay. So maybe I can use updates, I don't know. It's confusing. Also, this pending, because we're not on premium, is like really obnoxious. That makes me want to just go install the software and then be able to run it locally. Really, really annoying. Alright, so let's update seat on, or set ID equal ID plus 1. Something like this. Alright, it's about 40 minutes in here. So, yeah, it gives me an issue with my syntax, huh? Yeah, update seat from Alrighty, so I think we're only going to be able to use subqueries. I don't think we can use updates. I also don't think we can do more than one. I don't think we can do more than one command. Yeah. Yeah, I don't think we can do more than one command. That'll give me an error. There's no output, yeah. Okay. We've updated now, but it doesn't output anything, the update. So, okay. is, I don't know. I don't know how to do this. I gotta think about it for some time then. We can get the information that we need on one line, but each record. But the problem is that when we relabel, we need to somehow get the excuse me. You know what we can do? I have an idea. Well, how do we do this? I actually don't know. I don't have a good answer for this. So, I think, how do we write to a new... How do we do this? I think all we really have are the joins to create new rows. What am I missing? I'm missing something. I'm missing something here. be. How do I do this? I mean, you could run a subroutine. No, that doesn't make sense. I don't know, man. How do we get a row that has these it's interleaved? I forget what a join even does. Yeah, join is a Cartesian product of the rows and the columns, or just the columns. Yeah, just a Cartesian product. And outer join is basically you append these new columns to each row. You have a join on clause, so these elements that you're going to only use the ones where that on matches and that on is true. It's actually a little bit more complicated than that. It's a Cartesian product, so you're gonna get potentially a copy, like for every ID. Well, every row will get if there's two sets A and B, you'll get copies of A and B such that every row in A will get extended for each row in B. So you'll get potentially a lot of rows returned, which is pretty messy. Potentially. Interesting. I guess you can use, maybe that's what we need to do. Oh, that could be it. Oh, that's very interesting. Okay. Oh, I get it. I think I know what to do. I think you need to do an outer join with an on clause, and in the on clause you can put your if statement. And if you do that, then you can select exactly which. Oh, that's very interesting. Wow. Okay. I think that's what we do. I think I got it. I think I understand it. Oh. Yeah. That's a tricky thing. That is a tricky thing. I'll my head. Oh, my head. Falling over. Falling over. Oh. I got a missed call from the same number twice. Excuse me, I wonder who that is. Who is that? They have not left me a message. This person should leave me a message, and then I would know who's calling and why. Hey man, how's life? Why are you whispering? Hey, what's up, Devesh? Hope today's going well. Welcome. I lost my voice. If you hear me speak, you'll hear I sound like a sick person. Also, I lowered the volume a lot, or raised the volume a lot so I could speak lower. Hey man, it's all right. I'm taking it a day at a time. I'm surviving, but it's definitely challenging. It's definitely challenging. All right, we're gonna write our. Yeah, it's a lot easier in my voice to whisper. So I'm gonna go ahead and just keep whispering. We're gonna write this subquery. Let's see how this goes. We're gonna do a single left join this time around. Call it Y. Alrighty, so now we're gonna left join with seat as Y, and the on clause is the important part. This is going to be, we're going to say if, so if y.id, so if x.id modulo 2 equals 0, then we're going to say the condition we want is it's going to be excuse me. So if x modulo 2 is 0, I might need to update this too. That might not be the right expression. Okay. On x.id equals up.id minus 1. So it's going to be x.id equals y.id minus 1. Now, or it's going to be the other one. It's going to be plus 1. So if our ID in x is if our ID in x is even, or if it's odd, then what we want to take is the ID plus 1, right? The one below. So Abbott, for 1 we want Doris. For, excuse me, if it's even, so for Doris we want the one above. So subtract an ID. So yeah, so it's actually, but it's the other way around. It's YID equals, or it's confusing which one we pick. But it'll be, so XID 1 should be the one above, you subtract, or the one below, you subtract. So if we're even, it actually should be the other way around, I think. That's confusing. So if we're even, right, modulo 2 equals 0, then we want the 1. We want to match x plus 1. We want to match, or actually, no. We want 2. We're going to take YID plus 1. We're going to take 3. Or excuse me. Actually, that would be, yeah, matching YID plus 1 means actually we're matching the opposite. We're matching the so really we should do it the other way around. The one that we want is going to be XID. If we're even, then we want the previous previous one, minus 1. If we're odd, then we want the, if we're odd, then we want the one below. So YID is going to be XID plus 1. I think it's easier to do it this way. Specify the one we want in terms of what we're looking at. I think something like this is what we're after, I think. It worked. Hey, it worked. Can you imagine that? Wow. No kidding. Alright, and now we just select, are you ready for this? ID, and then Y student as student from this subquery. I think that's all we need, and then we're done. Every derived table needs to have its alias, okay. As a subquery. Oh no, there's a null. Uh-oh. I missed that. Okay. Hold on just a moment. What happened here? Oh, I see. Okay. Except the last value really should be itself. So that's a tricky thing. I guess we could use another if statement and say, you know, if we're odd and we're the last, yeah, so we can do, really there's another if statement here, which is a tricky thing also. So if, select count of from X. We don't want to run this subquery every time. That's really obnoxious, but I guess we have to do it. Is there a way to figure this out where we don't modify the last one? We can maybe do it this way. Instead of running that every time, just say if, another if statement here, if x.id plus 1 is equal to null, then we return YID equals XID. Otherwise, you take this one. Alright, how about that? How about that? Almost worked. It's very close. I don't know if I can easily get the row size. I don't really want to run a subquery every time. script. I don't want to run a Perl script for that. Select count. It's tricky. Maybe we can do no. Maybe we can do this. We really want. What does this look like? Row number. I don't know. I don't want to use MySQL variables though. You know. Well, also why can't I use the count? Why is that not working? Is that, hold on. Oh, that's why. Missing a comma. That's why. Okay, size. 2152. Oh, I see. Interesting. But if we don't include count, then it's fine. Interesting. Interesting. I see. just copy the size all the way through. Just let every row has access to the size. Just do 2 joins that way. I don't know. It seems really excessive. I mean, I guess we could do that. I guess we could run this subquery. So what happens if we do this? This just prints 1 row with the size on it. Yeah. Okay, it's not what we want. It's not quite what we want. I mean, I don't know. Is there like another way to get the count? Could do something like, is there a greater than? Oh, you can do something like, it's more like y of this value. Well, y of id equals null. Like, how do I don't, gotta lay down. What do we even do here? I don't know. Excuse me. So we just want the last element, if it's odd, to not change at all. But the problem with that is, so we would want to join with itself. But what's the condition that we do that for? Can we get the size and I guess we can get the size in an outer, in a subquery. Excuse me, but can we even do that? Maybe there's a function we can get. We can call to get the table size. Let's try that. Oh, let's see if that exists. Also, I got up way too quickly. Excuse me. What the table size were. Number of rows, number of records. It's not. Count is great, but that's not what we're looking for. Okay. Row number. Okay. Hmm. I guess you could just select. Like something like, I don't know, man. If this is let's do something like this. I don't know. Excuse me. Excuse me. And we're currently looking at x.id. Something like this, right? I don't know, man. Okay, that's not the right syntax. Can we do this? Oh wow, whoa. Wait, what? What? That was all I needed to do, are you kidding me? What? What? Okay, of course. Of course. Brother. Right, what? What? That's all I had to do? Okay, alright, fine. So, if we're odd and the size of seat is equal to the IDA, that's also odd, then we would select this one, otherwise we do x.id plus 1. Fair enough. Alright, and now all we need is select from this entire subtable, and we're going to select ID as ID, or yeah, ID as ID, and then sub.y student as student. I think that's all we need. Also, how much time do we spend on this? That was over an hour and 15 minutes. I think that's it. I think we're in good shape. Let's see if it works. Hey, we got there. Alright. Sweet. 0 bytes, less than 100%. Amazing. This is pretty slow, but it works. It works. Let's see what other SQL statements other folks had. So we have to modify a join to get this to work. Brother. That took so much time. That took so much time. Alright, so the discussions. 4-line solution using if statement using 2 union operators. 3-line MySQL. Alright, let's try each of these. Whoops. 1, 2, 3. Without using union and order by. Super simple explanation, elegant. 84%, no aggregates. Alright. Select if ID. Wait. You put the if first. Count from seat. If. As ID student from seat. Order by ID ascending. Case when does anyone know how to use if statement TSQL? I have to use case here, thanks. Interesting. 2 if instead of 3, select if. Tell me why. Tell me why. Dmod 2 as ID works here. If ID is less than this amount, and say if mod 2 in the other case, right? That's the same structure, basic structure I used. But you didn't need to join at all. Oh, and then it just sorts at the end. Oh, that's interesting. I like that. That's good. That's good. Student column is unchanged because they sort at the end. They sort at the end, that's why. That's a pretty good solution, yeah. It doesn't fail if it's even. That's not true. This shows some replies too, I guess. Or no replies. 3 solution line solution. That's pretty good. I didn't know you can use the if at the top here. That's good to know. 2 union operators. Even number of rows is odd number of rows. Union. What does a union do? Also max ID. What does max do and what does union do? We're gonna find out now. Let's see. Oh, I see. What's max do? Let's find out. So, union clause combines the results from multiple select statements into a single result set. Oh, no kidding. That's useful. 1, 2, select AB. Select 1, 2. 1, 2, 1, 2, select AB. Select 1, 2, union, select AB. Oh, I see. 1, 2, AB. Interesting. Select repeat A 1 time, union select B, repeat 20 times. Oh, okay, that's interesting. So yeah, we could have used two unions of the subqueries. We could have subqueried the join. Oh, I see. Actually, a union would have been very good here, I think. I suppose. Maybe, I don't know, actually. That would have been somewhat useful, though. Yeah, we could have made two copies, I guess, of, we could have joined, like, just the... We could have joined just the, well, interesting. I guess we could have taken two unions, right? Or two, union, two different joins on the seats, on the seat table. The seat table we could have done, a left join of the, we could have done like a left join of the table with the ID +1, and a right join, a left join of the table with the ID -1. And then we could have taken, we could have used a where clause on both of those joins. So where for only the IDs that are even, and on the other side, the where only the IDs that are odd. And then we could have taken a union of those two subqueries, and then sorted based on the ID, and then only take the, and actually you would rewrite both of those tables, right, to just the ID and the students. You'd update the ID and the student, so you'd have the odd IDs and the odd and the right students and the even IDs of the right students, and then you can union those and sort descending on the ID. You also could, once you've done that, then you can, once you've done that, you can, excuse me, there's one issue where you need to be careful if the odd, the last ID, if it's odd, there won't be, the last ID, if it's odd, if you have an odd number of IDs in the last ID, row shouldn't change. So you may need to, update that last row. I'm not sure exactly how to do that though. At the end, I suppose. Yeah, you have to be very careful to handle that correctly. The other two unions are fine, but I guess you just wouldn't. I'm not sure exactly if you just wouldn't include the last row and handle that query separately, or what to do. I guess you could make another union, that last row, you can derive that separately and then union that again as for the third row. So the way to derive that one, I guess you would take you can limit in the reverse direction the last row to get from, so your subquery could be the table in reverse order limited to 1, so that'll give you the last row, and then you could say reverse order in terms of the ID, and then you could say I guess you could join that with if, I guess you use an if statement or something. I'm actually not sure exactly what to do. gotta think about it. I guess maybe you don't want to union this subquery. I'm just thinking, how do you modify the second? How do you modify the other subquery such that you don't include the last value? I don't know. On your join. Gotta wash my hands. I'm sticking my hands in my face, but it's not helping. Give me a moment. I'm just gonna keep pondering and also wash my hands. Alright, yeah, you have to forgive me. I actually went off and thought about something else for some time. Forgive me for that. Also, my emails are still open. Why do I keep doing that? That's a bad habit. That's a bad habit. So yeah, just give me one moment here. Let me close this so that way it's not visible. Okay. So I guess what you would do is you would exclude the last row from your join, using an if statement maybe. So the second, the second union, you just exclude the last row. Like I said, I suppose using an if statement, and I suppose using a select query, or a select count query, and then for the last union, for the last row, then you can sort the table in reverse order on the IDs to get the limited to one row, just that row, and then say if the ID there, I guess you could retrieve that ID if that ID is. So then I guess what I would do is I would join again on perform another left join, and in the if statement check to see if that ID is odd, then you would just return the same value, and if it's even, then you return then you take the ID plus one. The ID plus one name of the student. That's a really tricky thing. I mean, I don't really know. I don't know. It seems like the way that I did it's probably better if you're going to do it that way. At that point, I think you should just do what I did. I don't know. Let me read his solution so I get a sense of what he actually did. I don't really get it. I see. Don't get the last row, so handle it next union. Interesting. Select max ID from C. That's the same thing as the count, really. So as long as the ID is not the last one. Even numbered rows as odd numbered rows. Odd numbered rows as even numbered rows. And then get the last if as odd. Don't change the ID value. And then order. Oh, that's interesting. And you can name. You don't need to use as to name. Oh, I see. You could just relabel. You could just relabel the IDs. That's an interesting way of doing it. Relabel this ID where the ID is even. Make it odd. All the ones that are odd, make them even, and just skip the last one with a subquery. And then the last one, let's say it's odd, and it's equal to the last one. And then we take that union. The last one won't be odd if we have an even number altogether, so it'll be included. So this is only if it's odd and it's the last one, we skip it. But if it's even and it's the last one, then we take it. Oh, I see. So actually this is cleverly written in such a way where we don't always skip the last row, we only skip the last row in the case where it's both odd and it's the maximum. Okay, that's very clever. I like that a lot. That's a good way. And then sort at the end. Very good. This beats through 99%. Oh wow, that's pretty good. Whoa. Whoa. Wow. for Python programs to be one line, but in Ruby programs to be one line. But actually, like, you could technically make like all SQL statements and all MySQL statements. No, excuse me. I think all SQL statements and all. I think I could be wrong. And all C++ programs, you could make them one line by just getting rid of all the new line characters and adding the right delimiters. So it's really not that big of a deal. But being very concise is, I guess, a big deal. So this is interesting. So it says select row number over, I don't know what that does, ID student from seat. Order by if mod of ID2 is 0. Okay, I see. Then you're going to say order by ID minus 1, otherwise order by ID plus 1. I don't think this is correct though, because it doesn't handle the last case correctly. What does over do and what does row number do? Row number over ID student. Okay. That didn't work very well. Maybe this is what we need. Okay, there we go. Where's over? I don't see over anywhere. What is this? Over function. There's no over. What is this? Current row, then it's partition. Each row. Upform a query form a calculation using rows related to that row. Aggregate functions can also be used as window functions. Interesting. Lag in current row within partition. Least lead. Let's try the rank number. Where's that? Oh, I see over. Oh, okay. Got it. Excuse me. So over is not, it's a keyword, not a function. So he's saying row number over ID student. Okay, from seat. Does this work? I don't think this works. This is actually function. See, I like the other solutions that other folks have or had, but I think I'm gonna go with the if statement in the beginning. I think it's better. So what is this? What does this do? Does this work? Can we get rid of these things? I guess that's the same thing if you don't, oh no, okay. I stand mistaken. So obviously, you don't need, I don't think. So what is this as a function? Like, what is this notation that we're looking at here? Excuse me, this is really weird. What does that do? have the current row, and then its partition. Row numbers range from 1 to the number of partition rows. Order by affects the row in which orders are numbered without order by. Row numbering is non-deterministic. So I think this is equivalent to as ID. I don't really know. I'm really confused. Where's the syntax? How do you know the syntax? Over as a function. What is that? What does that do? Is this correct? I have no idea. Apparently this is correct, and it's very efficient. Is this function what? In other words, is this just as ID, and then you don't need the as ID? Oh, I see. And you don't need to put as in there. Ah, that's very interesting. Okay, I get it. We're gonna try one more time. I think I understand now. So the syntax is that the over has a function. You can use group by. Only have the aggregated values of the columns that are not included by group by. In contrast, using windowed aggregate functions instead of group by, you can retrieve both aggregated and non-aggregated values. That is, although you are not doing that in your example query, you could retrieve both individual order quantity values and their sums, counts, averages, etc. over groups of the same sales order IDs. Practical example why windowed aggregates are great. Suppose you need to calculate what percent of a total every value is. Without windowed aggregates, you'd have to first derive a list of aggregated values and then join it back to the original row set like this. Whatever's happening here. Now, look, you can do the same with a windowed aggregate. So we select original partition, original.value equals 100 times 100 divided by total value as value percent original row set, original inner join, select partition sum value as total value from original row set, group by ag on original partition. Much easier and cleaner, isn't it? So you can just select the partition value times sum value over partition by partition as value percent. Brother, I have no idea what's going on here. What am I looking at? Brother, it's so complicated. It's not that it's complicated, it's just that SQL has a lot of syntax I'm not familiar with. Or MySQL has a lot of syntax I'm not familiar with. Only wanted to group by the sales order ID, then you wouldn't be able to include the product ID and order quantity columns in the select clause. If you only wanted to group by the sales order ID, then you wouldn't be able to include the product ID and order quantity columns in the select clause. Partition by clause lets you break up your aggregate functions. One obvious and useful example would be if you wanted to generate line numbers for order lines on an order. Let's see. Over partition by order ID. Oh, I see. So how does the over function work? What is this? Okay. So we really need to read these sections here, window function concepts and syntax. And then, so that's what he's using as a window function. Okay. Descriptions. Okay. Non-aggregate window functions that for each row from a query perform a calculation using rows related to that row. most aggregate functions also can be used as window functions. Okay. Non-aggregate window functions. But most can also be window functions. For window function usage, information examples and definitions of such terms such as the over clause, window partition frame in PRC 12.2. Okay, I should read that first then. Describes how to use window functions. Examples use the same sales information data set as found in the discussion of the grouping function. Group by modifiers. Sales information data set. Okay, that's fine. Select from sales order by country or product. Okay. Window function performs an aggregate-like operation on a set of query rows. However, whereas an aggregate operation groups query rows into a single result row, window function produces a result for each query row. That's what we need. The row for which function evaluation occurs is called the current row. The query rows related to the current row over which function evaluation occurs comprises the window for the current row. For example, using the sales information table, these two queries perform aggregate operations that produce a single global sum for all rows taken as a group and sums grouped per country. Perform aggregate operation that produces a single global sum for all rows taken as a group and sums grouped per country. So we sum profit as total profit from sales. Alright, so this is the aggregate operation. And then now you have select country, sum profit as country profit, so you have country and country profit from sales, group by country, order by country. Okay, so we group by, so total profit was going to be the whole profit column, sum is total profit. And then we have select country and profit, sum of profit as country profit. And then we say from sales, and we are going to group by country and order by country. I'm not sure what the order by exactly is going to do, but the group by should actually group. So we perform these aggregates on each of these groups. So we have each country's sum, and then I guess ordering by country basically will sort on by the country name. Okay, fair enough. Contrast, window operations do not collapse groups of query rows to a single row output row, so they produce a result for each row. Like the preceding queries, the following query is a sum, but this time is a window function. Oh, that's interesting. So now you can use a window function for sum, and you get total profit and country profit. The whole aggregate gets placed in the result. There we go, that's nice. That's very nice. That's actually exactly what I was looking for before, when I wanted the total size. I wanted that as a windowed operation rather than an aggregate operation. Window function rather than an aggregate function. So we have year, country, product, profit, sum product over as total profit. Now here's the interesting part. You can partition. So over the over function, this would be over everything. You can partition by country, and then I see. So now window function is going to be over all of the rows for a particular country. That makes a lot of sense. Okay, so the partition by, I get it now. Window operation, the query is signified by inclusion of an over clause that specifies how to partition query rows into groups for processing by the window function. The first over clause is empty, which treats the entire set of query rows as a single partition. Window function thus produces a global sum, but does so for each row. Second over clause partitions row by country, producing a sum per partition for the country. Function produces the sum for each partition row. So that's interesting. So for each partition, all of those rows will get this particular value. Okay, I get it. I get it now. Now I order by country name, the year, the product, and the profit. Interesting. That's interesting. Each window operation in the query signified by inclusion of an right, we got that already. Window functions are permitted only in the select list and order by clause. Query result rows are determined from the from clause after where, group by, and having processing and windowing execution occurs before order by, limit, and select distinct. Interesting, the over clause is permitted, so only in the select list and order by clause. Interesting, order by, so it can be in the order by, window functions can be in order by, that's interesting. Would have expected that. Query result rows are determined from the from clause after where, group by, and having processing and windowing execution occurs. After where, group by, and having processing and windowing execution occurs before. So windowing execution happens after the where, the group by, and the group by occur, and having process and windowing execution occurs before the order by, the limit, and select distinct. Okay, interesting. So it occurs before you order, but after where, group by. I forget what group by does. Over clause is permitted for many aggregate functions, which therefore can be used as window or non-window functions, depending on whether the over clause is present or absent. Very interesting. About each aggregate function, see also supports non-aggregate functions that are used only as window functions. For these, the over clause is mandatory. So here you go. These are not aggregate, but window functions. Details about non-aggregate functions, see window function descriptions. Aggregate function descriptions. As an example of one of those non-aggregate window functions, this query uses row number, produces the row number of each row within its partition. In this case, rows are numbered per country. By default, partition rows are unordered, and row numbering is non-deterministic. To sort partition rows, include an order by clause within the window definition. The query uses unordered and ordered partitions, the row num1 and row num2 columns, to illustrate the difference between omitting and including order by. Okay, interesting. Excuse me. A little bit about the over clause. Window spec, window name, partition clause, partition by expression. Alright. So there's more information here about the order by and the order clause and the partition, partition by, partition clause. There's even a frame clause. I don't really know what all these things are, but I wanted to review before I went into that. Something else, I forgot what it was. What does it say? Partition row. By default, partition rows are unordered and row numbering is non-deterministic. Okay. Alright, fair enough. To sort partition rows include an order by. What does order by do again? Or no, I know what order by does. What does group by do? Group by. What does that do? I'm saying that this is not legal. Because c.name doesn't appear in the group by. Oh, I see. Okay. The name column must be omitted from the select list or named in the group by clause. Oh, that's interesting. Huh. That's if you have. That's interesting. I don't know what. I just want to know what group by does. I wouldn't have expected that, by the way. But what does group by do? examples. Okay, this is not. Where is? Somewhere's got to be a group by. Oh boy. Why is this so difficult? There we go, group by modifiers, okay. Group by clause permits a with roll-up modifier that causes summary output to include extra rows that represent higher level, that is super aggregate summary operations roll-up. This enables you to answer questions at multiple levels of analysis with a single query. For example, roll-up can be used to provide support for OLAP online analytical processing operations. Suppose that a sales table has year, country, product, and profit columns for recording sales profitability. Okay. Summarize table contents per year. Use a simple group by like this. So group by year, profit sum. So I guess basically group by is for aggregate functions, and more or less it defines what the aggregates are going to be. So things that share that particular value, I guess, those become aggregated. Total aggregate profit for each year. Okay. With roll up, what does that do? So now you say aggregate profit sales group by year with roll up. All right. So now our year. Oh, I see. So you got yet one more. You can aggregate one more time of everything. That's interesting. Grand total. Okay, that's super aggregate row. That's interesting. Multiple group by columns, more complicated. Each time there's a change in value in any but the last grouping column, the query produces an extra super aggregate summary row. Oh boy, this is gonna get complicated, huh? Summary of the sales table based on year, country, and product might look like this, where the output indicates summary values only at the year, country, product level of analysis. So if you group by year, country, and product, then you could say year, country, product, profit, the sum over that. Oh, I see. So you can create all these aggregates over this table, and you'll get all of them, right? You'll get, for a given year and country and product, you get the profits. You'll get all those possible combinations, right? And then if you roll up, then all those combinations, I guess you get for everything total profit, you'll get for just 2001, you get the profit, right? For just 2000, you get the profit. So each of all those different possible super aggregates. So in only 2000 in Finland, you get and you get 10. Right, I see. That's interesting. So only in 2000 in the USA is what you get. Only 2000, you get this. So these are all the different sort of, basically it's like a Cartesian product of the different possible aggregates that you could have. That's interesting. Or not as Cartesian product, but it's almost like every permutation, maybe. It's the way I think about it. I actually don't even know how you describe it exactly. I don't even know how you describe it. 4 levels of analysis. Each year each year and country. There's all products. Given year, row for all countries and products. And then for all years, countries and products. Okay, I see. So actually, you just break down one at a time. You don't just like, it's not actually
every combination. That's what I was thinking. It would be a power set. It's not every combination. Not exactly. Every combination would be more complicated because you would have null years. Like if you just did just the product, so just phones, you'd have null no phone, which you don't have. So it doesn't do every combination, possible combination. It takes it's just the combinations left to right. That's interesting. Okay, but that's the with roll up. Alright, fair enough. There's a grouping. Oh boy. And what does this do? Ouch, my foot. Oh. My feet are aching. I haven't stood on my feet for this long in a long time. I set up a makeshift standing desk, so make sure that I stand during the day, so that way my back kind of straightens out a bit. Yeah, we use limit after roll up. It gets really confusing. Wow. Pretty interesting. I don't know, grouping, substitute labels. Interesting. Grouping. Name equals 1. All items. All sizes. Interesting. Size equals 1. All sizes, all items. I don't really know what's going on here. There's a null size, I guess. Interesting. So, alright, anyway. So that's all well and good. Let me, I don't know what the grouping does. There's also some syntax here I'm not familiar with as well. There's also this syntax. Like, what are the MySQL operators? Right shift. Null safe equal to operator. Not equal operator, okay. I was wondering. Okay, fair enough. Is in. Interesting. Like. Not in. Okay. Fair enough. Fair enough. Okay, I think that's probably enough studying MySQL for now. Hopefully that's enough for our particular solution here. So why do we know that this is correct and this works? Also, it seems to run kind of slowly. So row number over ID student. So it's going to take, okay, I get it. So the ID is, now that's kind of weird. Oh, I see. So the row number is going to be over the whole. So this is really interesting. It's a window function over the entire, wow. So it's a window function over the entire table, but it tells you the row number of that particular row. So it will actually give IDs IDs. Like as you're moving through the table, it'll actually give you the IDs. And then it's order row number over ID from seat with an order by student. And now we say order by if. So what does that mean, order by? Now we have to take a careful look at the order by clause. What does that do? Because this is pretty subtle. What's happening here? It's very subtle. Describes what MySQL can use an index to satisfy an order by clause. The file sort operation when used when an index cannot be used, and execution plan information available when from the optimizer about order by. Order by with and without limit may return rows in different orders, as discussed. Limit query optimization. Uses of indices to satisfy order by. In some cases, may use an index to satisfy order by clause and avoid extra sorting involved in performing a file sort operation. Index may also be used even if the order by does not match the index exactly, as long as all unused portions of the index and all extra order by columns are constants in the where clause. The index does not contain all columns accessed by the query. The index is used only if index access is cheaper than other access methods. Assuming that there is an index on key part 1, key part 2, the following queries may use the index to resolve the order by part. Whether the optimizer actually does so depends on whether reading the index is more efficient than a table scan. If columns not in the index must also be read. In this query, the index on key 1 part 2 enables the optimizer to avoid sorting. However, the queries select, which may select more columns than key 1 part 2, key part 1, key part 2. In that case, scanning the entire index and look up table rows to find columns not in the index may be more expensive than scanning the table and sorting the results. If so, the optimizer is not likely to use the index. Only the index columns the index is used in sorting is avoided. Interesting. InODB table. Well, let's forget about the InODB table for a moment. What does order by do, though? You know, I don't know. If an index cannot be used to satisfy an order by clause, MySQL performs a file sort operation that reads the table rows and then sorts them. File sort constitutes an extra sorting phase in query execution. To obtain memory for file sort operation, optimizer allocates a fixed amount of sort buffer size bytes up front. How much memory does this use? None. Okay. Order by optimization. Execution plan information. Explain. You can check whether MySQL can use indices to resolve an order by clause. Okay, that's not really what I'm looking for, though. It's not really optimization that I'm looking for. It's more just like order by. This is so annoying. I'm just looking for syntax, and I get optimization. Okay. Seen the following syntax. Select from order. Oh wow, check it out. Unusual ventures. 140K to 200K, not bad. Oh, you know what? That's very subtle. This is a recruiting company. That's why these numbers are so high. If it was the company themselves, they probably wouldn't advertise it that high. Almost certainly this is a recruiter. We can click on it. Our companies. Yeah. This is a recruiter. This is a recruiter. Almost certain. I'm pretty sure. What a node sorting will be, just add the order part by part in select SQL fiddle. Create table insert. Select order by data equals B, sending. What's the result? Interesting. No host of this type available to create schema, different database version. I don't know. Oh. Whatever, I don't know. I don't know what's going on here. Maybe I shouldn't click on this. That's kind of questionable. Whatever it was, I just clicked on. Not limited to sorting by sorting on values of existing column. You can specify complex expressions inside your order by clause. Query sorts by the value of a Boolean expression. The expression will be true for the rows where column equals B and false in all of the rows. As a result, rows with column B will come first because the order by clause specifies descending order, and in SQL, true is represented as 1 and 0 is false. False is 0. Oh, I see. Okay. So what you're saying is you get a number, I guess, for each row, and you're going to sort by those numbers. Okay. Now, what's interesting is the last row. So if it's, oh, I see, well, the order by allows you to not have to deal with the last row. Because if you modify that last row, now I guess one question I have is how come, what if we remove this altogether? First things first. It's wrong, okay. Let's undo that before we do anything else. I have a few questions. What happens if we remove that and why? The second thing is, why do we not need to consider the last row? So, oh, I see, if we remove that, then yes, we're ordered correctly. However, we have the wrong indices with the wrong row values. So we have the correct order of the student values, but not the, we need to actually rewrite. So what it's going to do is use the ID from the seat. So you can say as X, and you can say X.ID, I believe. Now what if you did this? I think this will give us what we want. There you go, okay. So, oh, I see. So this will rewrite, basically this will rewrite the row number that you need. So this is confusing, but right, the ID it's being referenced to here is not the ID it's being referenced to above, which is very, very subtle, very interesting. Personally, I'd probably include that there's actually two different IDs that are being worked with here. So the ID at the top is intended to overwrite this second ID. This ID gives you an ordering. Now, how that works, it will give you, so if you're equal to 1, so you're false, it'll swap your ID with whatever is, I guess, above or below. It won't actually swap. It'll swap the ID, but it'll give each row its own index value in the sorted order at the end, relative to the other values. So if this value is larger for one row, then it'll be sorted further down than the other value, assuming this is descending order, and vice versa. If there's a value that's larger, if it's larger, it'll be further down. If it's smaller, it'll be further up. in the result. Now what's interesting is that even though if you have the last row, if the last row is odd, is even rather, is even. No, yeah, if the last row, if we're odd, excuse me, then what you can do, this will fail, and you'll end up here at ID plus 1. But what's really interesting about that is that it's still in the right position. That last row, it's still the last row, so it handles that case correctly. If it was the second to last row, then it would get swapped. So that's really a really subtle but interesting maneuver here, is that the sorted value that you end up with, it's still larger than all the other values, so it still ends up at the bottom, which is exactly what you want. I think this is the best solution, in my opinion. This is extremely concise. The only reason why this might not be the best is that, yeah, there we go. It's pretty fast. It's pretty fast. The only reason it might not be the best is that this window aggregate is kind of subtle, and or this window function is kind of subtle, and I don't know how much extra computing is required to use this window function. But basically, you just use this window function to overwrite the ID. And that's it. So everything gets sorted in the right way, and then you just overwrite the ID with the window function. And that's it. Override each ID with the window function. Pretty smart. Pretty smart. I like that a lot. Oh yeah, this beats 99%. Yeah, this is the really fast one. Yeah, I think this is probably the fastest. Probably the fastest. That's phenomenal. That's interesting, the if function being the order by. Yeah, that's really clever. Really clever. I like that a lot. I was going to say, yeah, we can also use the if function in the, so another solution is to use the if function in the select statement, but I don't like that as much. There's double if, and we say if, we're going to say as ID. You don't have to have the as, but you say ID, student, from, seat, and then order by ID, and then we want to say descending. So here we can rename the ID, which is interesting, and this is going to be here we can select count from seat. Let me say if that's modulo 2. Then we do certain things. And then if there's another statement here, another expression, then we do certain things. So if, I guess we could just do ID modulo 2 equals 0, then we can say, so we can do as x, we can say x.id. Oops. You don't actually need to do that though. We'll do that for now. X.id, yeah, so you can put all the if statements in the beginning, and then just order your ID at the end, and you can do that as well. And this is an as ID, but you don't need that. You also don't need the as here, you can just put the x here. Okay, so you could say, if we are even, then we're going to return, so if we are, for ID is even, then we want ID minus 1, right? And if we're odd, then we want ID plus 1, normally. But if we are odd, and the size of the table is also odd, so if we're odd, and the size of the table, or excuse me, if, no, I take it back. If we're equal to the size of the table, I take that back. So if we say if x.id is equal to the size of the table, then return x.id. But if we're not the size of the table, then it's xid minus 1. Or the odd ID you want to relabel as the odd values you want to move down to become even. Yeah, odd values get a +1. Even values get a -1. Right? Oh, excuse me. Yeah. Oh, I'm sorry. This is even. Odd gets a +1. Whoops. That's very confusing. But something like this, and then we sort in descending order. Let's see what we get. I think I've made an error somewhere. Oh, we need another closing parentheses here. How are we doing on time? 2.5 hours, okay. So, oh, it's ascending, I'm sorry. Should be ascending. There we go, done. And let's give that a shot and see if we're correct here. Yeah, that's also pretty quick too. That's also relatively fast as well. Now what's tricky is that you actually don't need to put this X here. And that's a little bit confusing. But it's true, this ID is coming from the table. It's not this ID. This is just an alias, this one. So both of these are reasonably fast. Right? Both of these are reasonable. I don't like this one as much though. I think the other one was a lot more clever. The other one was we're gonna use a row number window function to rewrite the ID. Now we're gonna order by our mod function. It's gonna be ID2 equals 0. And we're gonna say ID minus 1 and ID plus 1. And if we say if our I think, by the way, you could just do ID modulo 2. I think this works too. What we're saying is, if we're an even value, we're going to order this in a way that is, if we're an even value, we're going to order it as if it's odd, as if it's one less. We're going to order it above. If it's an odd value, we're going to order it one down, as if it were even. And this works nicely because the very last row still gets into the right spot because it's odd and it would go to the even spot, but there's nothing else to move it past. So it just stays where it is. I like that one. I like this the most. Now what's interesting is that this seems to be a little bit slower if I use ID% instead of mod. And I'm not sure exactly why. So I think this is pretty clever. But the first, so they're both relatively slow though, both options. And the reason is that, let me copy this. Let's see if this still works. I think both of these solutions are quite good. I think the reason the second one might be a little bit slower is, well, actually these are both pretty fast, actually. They're both kind of slow only because this select from, I don't know how often this needs to be executed. And this, I guess in theory, if it were optimizing things, this would be executed once in both. Well, yeah, I mean, this window function kind of gets executed as you go. I don't really know. Also, I'm not sure if it's more efficient to use the mod function or to put this % percent symbol directly in there. But they both seem to be about the same speed. This one, well, this seems to be a little bit faster. This with the window function. I think the one with the window function is a little bit faster, I guess, because we don't need to perform this too often. Something like that. I don't know. I don't really know. They both seem to be about the same speed. It's kind of random which one's faster. Yeah, sometimes this is kind of slow too. So who knows? But those are both extremely concise and very smart ways of doing this. Put the if statement up here rather than, like what I was doing was a join, right? And using an if statement within the join, which is very similar to this if statement. But it's not necessary to do that. That's a lot less efficient. So there you go. Alright, thank you for watching. That was an interesting foray into some SQL. Obviously, I need a little bit more practice in SQL if I want to solve these quickly. So thank you for watching. I'll talk to you soon. I think I'm gonna go take a break, just hang out for a bit, and then come back and we'll take a look at another C++. We'll take a look at another C++ problem instead of an SQL problem. All right, take care. Bye.